Yesterday we talked about three different variables, pressure, volume, and temperature, and we showed relationships between them by holding something constant. And if you look at those three equations, so we had like P1 V1 equals P2 V2, V1 over T1 equals V2 over T2, and then P1 over T1 equals P2 over T2. So if you look at your notes, it makes more sense. If you squish all of those into one equation, this is what you get. So this is the combined gas law, and this is really the only one of the equations you're going to have in the reference packet. So the three we did yesterday are not in the reference packet, but you can find them using this equation right here. So if you see in the question that temperature is held constant, you just ignore temperature from this equation. So if you cover up the T's with your hand, you see that you have the first equation we did yesterday. If volume is held constant, you just ignore volume from the equation, and now you've got P1 over T1 equals P2 over T2, which is what we did yesterday. And same thing with pressure. If pressure is held constant, ignore it, and now you've got the equation you need. So you kind of get all three from yesterday, but they're just smushed into one big equation. And sometimes you'll have to use this if nothing is held constant. So for example, it says a gas at 0.974 atm, so that's your pressure. Go ahead and label that as P1. 25 degrees Celsius. Anytime you get a temperature for this chapter, you need to convert it to Kelvin by adding 273. So I would go ahead and cross off 25 degrees Celsius and make it 298 Kelvin, and that's your T1. Occupies a volume of 27.5 milliliters, so that's your V1. The question says what volume, so we're going to look for a new volume, so V2 is our variable, will the gas occupy at STP conditions. So keep in mind that anytime you see STP in a question, it looks like they're just letters, but I'm actually giving you a temperature and I'm giving you a pressure. So standard temperature is 273 degrees Kelvin. You can just look that up in your reference packet. And pressure, standard pressure, is in your reference packet as well. You just have to make sure it matches the unit that you have. So since our initial pressure is in ATM, you want to look at your list of standard pressures and choose the one that is also ATM, and it should be 1. So these are our five things that we know. These last two over here, the 1 ATM and the 273K, these are STP conditions. You just have to look those up in your reference packet. Then it's just a matter of plugging everything in and solving for your variable. So here's our equation, and probably the best way to do it is to cross multiply. So you would do 0.974 times 27.5 times 273 equals 298 times 1 times V2, and that'll get rid of the fractions for you. And I want you to pause this video and go ahead and type it in your calculator and make sure you're typing it in correctly. If you do it correctly, you should end up with 24.5 milliliters. So take a break for just a minute and see if you can get that correct, and then move on to the next one. The next one is called Avogadro's law, and this is going to relate volume to moles when temperature and pressure are held constant. So Avogadro's law says that at constant temperature and pressure, equal volumes of gases contain the same number of molecules. So if the volume goes up, the number of moles will also go up. They're directly related. And the problem with moles is that it starts with an M, like mass, and so we can't use M as our variable because it's too confusing with mass. So in science, they use the letter N instead of M. So anytime you see N, you need to think of moles. So this is our new equation. Notice that the variables are being divided. Anytime you divide variables, they're directly related. And just like before, you just pick out the information from the question and plug it in. So if you have 2 moles, that's N1, of a gas in a 4-liter container, there's your V1. How many moles would you end up with? So you're looking for N2 if it fills a 3-liter container, so there's your V2. N1 is 2, V1 is 4, N2 is what you're looking for, and V2 is 3. So plug them into the equation. Volume's on top, moles are on bottom. And then you just have to calculate it. So if you're cross multiplying, you would do 2 times 3 equals 4 times N. So it would be 2 times 3 divided by 4. And the last one for today is called the ideal gas law, PV equals nRT. This one is in your reference packet, so you don't need to memorize this one. Go ahead and pause the video and take a minute to write down what all these letters stand for, and then I'll walk you through it. So P stands for pressure, And the major thing with this equation is that your pressure units need to match your units for R, and I'll talk about that in just a minute. Volume is the V, and for this equation, volume has to be in liters. So I want you to put a star by liters. For the other equations, it didn't matter if it was in liters, it just had to be in the same on both sides. So you could have had milliliters as long as you had V1 in milliliters and V2 in milliliters. But for this equation, anytime you use PV equals nRT, you have to put your volume into liters. N stands for moles, T stands for temperature, and again it needs to be in Kelvin. And the new one here is R. So R is called the ideal gas constant, and a constant means it's not a variable. So you will never solve for R. You're never going to try to calculate that. R is always given to you in your reference packet. So I'll never say what R is in the question. You'll just have to look it up in your reference packet. And if you take a minute and look in your reference packet, it's on the very first page where it says Chemistry Reference Tables. It's the second thing on the top left corner. You should see where it says gas constant parentheses R, and then notice that there's three choices. Those three choices are dependent on your pressure units. So if your pressure is in ATM, you want the R value that has ATM in its units. So if you look at those three R numbers, notice how the first one, 0.0821, has ATM in the units. So anytime you have ATM for pressure, you're going to use 0.0821 for R. If pressure was in mmHg, you would use the second one, 62.4. And mmHg and torr are actually the same thing, so you can use that one for torr as well. Let's go through one of these just so you can see how to set it up. So the question says if you have 0.622 moles, so that's N, on top of that put N, of a gas occupies 9.25 liters, that's your volume, so put a V on top of that. 15 degrees Celsius is your temperature. So go ahead and cross that off and make it Kelvin. Add 273, and that's your T. It says, what is the pressure in units of ATM? So we're looking for P this time. So we're looking for P. We're given volume, moles, and temperature. R is the only one that we weren't given. So since I wanted the pressure in ATM, you're going to look in your reference packet and find your choices for R, and choose the one that has ATM in the units. And it should be 0.0821. Then you just plug it into the equation. So the equation is PV equals nRT. So pressure is what you're looking for. Plug in your volume, your moles, the R value, and the temperature, and then you just have to calculate it. So multiply these three and then divide by 9.25. And you should get about 1.6. Let's do one more together. This one's a little bit different, and for this chapter, the hardest part is just picking out which equations to use. So if you're kind of stuck on what to do, what I want you to do is list everything that you know. So the question says, what is the volume? So I want you to write V equals question mark of 12 grams. And we haven't actually done one with grams yet. Grams does not tell you moles. Grams tells you the mass. So I want you to write mass equals 12g. It's at STP, so remember when you see STP, I'm giving you two different numbers. So standard temperature is 273. Standard pressure, you can choose whatever pressure you want because I didn't tell you which one to use. So I'm going to choose ATM just because standard pressure in ATM is 1, and that's an easy number to use. So if you look at your list of variables, we're looking for volume. We have mass, temperature, and pressure. So if we wanted to use the ideal gas law, PV equals nRT, we're looking for volume. We have everything we need to solve for volume except for R, which we can look up on the reference packet, and N. So N stands for the number of moles, and that's not given to us in the question. But notice what is given to us. It says that we have 12 grams of CO2. So at this point in your chemistry knowledge, you should be able to realize that you can convert grams into moles. So here's are the three things that we know from the question. Because you know the molar mass of CO2, you can use that to solve for the moles. So we have 12 grams. The 44 came from the periodic table. So we have 2 oxygens. 2 times 16 is 32, plus 12 more from the carbon should be 44. So 44 grams per mole, divide that through, and that'll give you your moles. And you just had to look up your R value. Since I chose ATM for pressure, I used the R value that has the ATM in it. And then it's just a matter of rearranging the equation to solve for V. So 0.27 times 0.0821 times 273 divided by 1. and you should get something close to 6. Notice that it's in liters because the unit for R is also in liters. It's really important that you practice some of this stuff because it's getting a little bit more challenging. So on worksheet 7, it's going to allow you to use the combined gas law, and worksheet 8 will allow you to practice with the ideal gas law, this one that we're doing here. So I want you to spend some time practicing on worksheets 7 and 8 and make sure you check your answers as you go. And that is all for today.